Hello everyone, good morning, good evening. This is Hemant and I welcome you all to this webinar on data science in action on behalf of Cognixia. I welcome you all and thanks for joining this webinar. And thanks for your overwhelming response. I can already see hundreds of like more than 300 participants have joined the webinar, yet, and we can see still the count is increasing. So thank you all for all your, participation, your interest, and we are right on time. And I hope all of you are able to hear me without any problem, and also you can see my screen. Okay. And let me introduce a little about this webinar. So as you know, this is going to be a webinar on data science, and basically we are going to talk about data science in action by taking one use case, one case study from the real world, like how that case study has been implemented and it is helping the organization. But apart from that, we are also going to start something with very basic actually, in order to make sure like we understand what is data science. So we are going to start from the very beginning. So let me very quickly go through the agenda for today's webinar. Okay, so these are some high level topics that we are going to discuss in today's webinar. We are going to start with the introductory concept, the introduction to data science. We will talk about this very important question, what is data science, and we will make sure we actually understand what is data science. Then we will talk about the data science toolkit, the most confusing question ever. What exactly am I supposed to learn? Okay, if I want to be a data scientist, if I want to get into data science or machine learning, then exactly what technologies, programming language one should learn. So we will talk about that as well, and basically we will go through all the aspects of a data science project, and based on that we will try to answer this question at the best, what exactly you need to learn. Then in the third, we will talk about the crisp DM model, which is nothing but a very famous, a very standard model, a life science, a data science, life cycle model, which is used, across the globe by all the enterprises, by all the organizations in order to implement a data science or machine learning project. We will see in real world how a data science project is actually implemented, is actually deployed, is actually used, what different phases generally we have for a data science project. Finally, in the last we will talk about a case study, and that case study is going to be about Uber Eats. Okay, so most of you would be familiar with the very famous app. There's an application, mobile application, Uber Eats, using which you can order your favorite foods from all the restaurants available in your neighborhood. Okay, so basically most of you would be aware of this particular application very well, but we will talk about a particular data science or machine learning use case that Uber Eats has implemented, and we will try to understand how they have implemented this exactly, how the solution works, so that all of you can actually understand how data science is implemented in action, how data science works in action. Okay, so that is going to be the main agenda for today's webinar. So thank you again for joining, and I can still see many participants are still joining, and the number has increased so far beyond 500, and we can see still more participants are joining. But I think it is right time we can proceed further and we can start with today's session. And those who will join this webinar in between, they are most welcome. Okay, so having said that, let me share one more thing before we start. So you all please feel free to ask your questions during the webinar. You can raise your questions, you can ask your questions using the question utility. I hope all of you should be able to see that utility on the go to meeting control panel, and there you should be able to post your question in the question uh, tab, and I will complete the topic that I'm going to cover first, and as soon as I will finish the topic, I will pay attention towards your question. So basically, like this particular course, this particular webinar has been divided into 4 sections. So after every section, I will pay attention towards your questions, and I will try to answer as many questions as I can. Okay, so you can feel free to post your questions, and I will make sure as soon as the current section is completed, I will pay attention towards your questions, and I will answer your questions in timely manner. Okay, so that's it, I think, and I hope everyone is fine, and we can go ahead and start with the session. So let me make sure we do not have any issues with any participants. Okay, so someone is asking, like, can I move back and forth through the video? So it's a live webinar, so I'm sorry, but you will not be able to do that. It is going to be a live webinar, so whatever I'm going to deliver from here, you will be able to be on that particular moment only. Okay, and okay, so let me start before asking the technical questions. So I have already started getting some technical questions, so let's give it a push. Don't ask any technical questions as of now. We haven't started the session yet. Okay, so firstly, let us start the session, and we are going to cover some topics, and then you can ask the questions for sure. Yet we are starting the session from the beginning. Okay, so we haven't started the session yet. We are going to start it now. And regarding all the queries related to PPT, recording, or anything, please feel free to, you must have got an email from Cognixia. So this type of queries and questions you can definitely ask using email as well. Okay, so for the time being, we can focus on this particular webinar. And okay, so agenda I have already mentioned. So Hitesh or Pratik, we are going to cover data science, some introductory concept of data science. We will understand firstly what data science is, and followed by that we will understand data science project life cycle, data science project toolkit, what exactly you need to learn basically. And then in the last, we are going to talk about a case study in data science. Okay, so we are going to talk about a case study which is actually about the Uber Eats application, how they are making use of data science application in real world. Okay. Okay, so for this particular webinar, you will not learn Python. It's a webinar actually, so we cannot cover some programming language, or we cannot cover any implementation part from the coding point of view. Okay, it's going to be the concept part. Okay, it's going to be the idea. So the expectation from this particular webinar would be to make you comfortable, like, okay, so that you can become comfortable with data science, you can understand how exactly how exactly the data science is being implemented in real world in the organization. Hey Abhishek, so basically this is a webinar, so in order to execute webinar in the timely manner, generally the participants are put on mute, and you can feel free to ask your questions using the chat window, using the questions window. Okay. Okay, so yeah, so Pranav is asking, yeah, for sure, Pranav. So basically, I am having around 10 years of experience in the fields of business intelligence, data warehouse, data modeling, statistical analysis, advanced analytics, data science, machine learning. So from last 4.5 years, I'm mainly into data science. So I am working as a data scientist for one of the leading analytics organization based out of India. And apart from that, in my extra time, I am also conducting this type of webinars for all of you. So that's it from my end. Okay, so having said that, let us go ahead and start with today's webinar. So I would request all of you to not to post any more questions. So I'm now going to switch to the content, and we are going to start with the webinar session. Okay, so let's go ahead. So the very first slide for today's session, introduction to data science, and the biggest question among the aspirants, among the participants would be, what is data science exactly? How can we define data science? What exactly, a data science project is implemented? How can we very simply define data science? These are some very basic questions. These are some very important questions that generally, data science aspirants have, and they look forward to the answer. For this particular question. And generally, unfortunately, even I have seen some folks who are still working in the fields of data science and machine learning, but they are not able to, express this. They are not able to, explain this very accurately, as in what is data science. Okay, so let us make sure, before starting with anything else, before going into any detail, further detail, let us make sure we understand what is data science. Okay, I will firstly go through a very standard definition of data science, and then I will try to explain this definition in very simple words, in the layman language, so that everyone can not only learn this definition but understand this definition. Okay, so the expectation should be, we know exactly what is data science, rather than memorizing some definition available in the books, in the references, right? So let me go through this particular definition of data science. So data science, also known as data driven science, is an interdisciplinary field about the scientific methods, processes, system to extract the knowledge or insights from data present in various forms, either structured or unstructured. So this is a very standard, very accurate definition of data science, but we don't need to remember this definition. Okay, and even if you remember this definition and someone is asking you what is data science and you are giving this answer, believe me, that is not going to make your work. Okay, so the expectation is you understand what is data science. So now let us try to understand this definition in real, in actually general language. Okay, in simple words. Okay, this is too much theoretical definition. So data science is about data, definitely. That is why it is known as data driven science. The central entity here is data, and we want to drive something using that data. The organizations have data. The organizations having rapidly growing data. So we have data there, where that's why we have big data platforms, we have data warehouses, we have data lakes. So we have data everywhere. In fact, we have too much data even in our personal life, that now we are unable to manage our personal data efficiently, right? Sometimes we face this type of situation, like, oh, my important photographs have gone, I could not save my photographs, I could not save my documents, so my system got crashed, my pen drive stolen. Okay, or simply they got deleted. So we are like clicking too many photographs nowadays, we are shooting the videos, we are having too many documents, everything is online, we have important information available online, on the emails, in the documents. So even we are not very efficient to manage to organize our personal data. Then think about the organizations, the big organizations, what type of challenges these organizations would be facing to manage their data, which is huge. Okay, so our data is nothing. So they have huge amount of data. And you know what, there is one more challenge, and that can be understood as challenge or opportunity. Like, our personal data is personal. Maybe it is important for us because it is personal, right? But for organization, their data is not only private to them, it is about their business, but this data is something which can generate even revenue, which can generate even more business for them. Okay, that's why the challenge for the organization is not only having the data or organizing the data or managing the data, but the challenge here is to understand the data, interpret the data, and making use of that data. Okay, so that is where data science is helping. So again, what is data science? Data science is data driven science. The central entity, the important part here is data. Okay, now what about this science part? Okay, so data science makes use, in data science we makes use of scientific methods, processes, systems. Okay, so these keywords, scientific methods, processes, systems, are what? So when you have some statistical programming language like Python, R, SAS, okay, the platforms, the operating systems, the technologies, the visualization tools, then your database systems. So everything, these are nothing but the scientific methods or tools or systems, right? Apart from that, what do we have? We have algorithms, we have science basically present in any format, maybe an programming language only, maybe a concept, a theory, an algorithm, a hypothesis. So any form of science, science present in any form, which can be applied on the data that we have. Okay, so firstly we have data. That data can be present in any format. Okay, your data can be structured data. The structured data is nothing but when your information or data is present in the row column format, like Excel sheet, like relational database tables, that is known as structured data. On the other hand, unstructured data is like the remaining type of the remaining everything that you can think of, like the information present in the free text format, information presents in the HTML format, information present in vector format, even information present in binary format, image data, audio data, video data. So these all are example of you can say unstructured data which is not present in the perfect format, but definitely it is data and we cannot lose this information, right? So data can be present in any format and we have a lot of data. The conclusion is that data science is nothing but when you make use of any scientific method, process, system, tool, technology, theory, concept, algorithm, programming language, whatever you can think of. Okay, in order to extract the knowledge, the insight, okay, from the data, then that is known as data science. Okay, so we have data, we have science, we combine these two things together in order to extract the knowledge, in order to extract the insights. Now when we say knowledge or when we say insights, it is not the usual knowledge, it is not the obvious type of knowledge or obvious type of insights. That is the biggest difference between business intelligence and data science. Okay, so some of you must be from the business intelligence background and you must be working on some BI tools like dashboards, Tableau, Spotfire, ClickView, right? So these are some examples of dashboard tools, these are some examples of business intelligence application with the help of which generally we utilize the data, we understand the data, and we present the findings present in our data in the form of visual analytics, in the form of charts, in the form of dashboard like bar plot, box plot, pie chart, line plot, a scatter plot, right? So these are some different type of visualizations or plots we use generally in business intelligence, right? But if you notice one important difference between business intelligence and data science, that business intelligence talks about what is very obvious. Okay, business intelligence talks about what is actually obvious information present in your data. Okay, like when you have sales information available, then you represent that sales information effectively in the form of bar plot or in the form of line plot, so that you can see like quarter over quarter how your sales is going, quarter over quarter, month over month, your revenue is increasing or decreasing, right? How your business is doing across different areas, across different regions, right? These are some obvious information. We are showing what is happening. Okay, so when you show what has happened or what is happening, then that is business intelligence. Okay, but now try to think about data science objective. Data science does not talk about what is happening or what has had happened, but data science also talks about, or data science mainly talks about what can happen in future, or what can be the reason of happening. So data science talks about if a particular thing has happened, then why that has happened. And also data science talks about what is going to happen in future. So that we call as descriptive analysis and predictive analytics or predictive analysis, right? That is what makes data science different from traditional business intelligence. Okay, so in short, traditional business intelligence talks about what is happening and what has happened, but data science talks about why it is happening, and data science also talks about what can happen in future. That is what makes data science distinct. Okay, so I hope now this is also one of the biggest questions generally we have among the participants. So I think this should be clear now. So likewise, if we go further in detail, then we can go through this particular definition as well, but we have already covered actually. So data science employs techniques, theories drawn from the wide range of disciplines like mathematics, statistics, information science, computer science, in particular from the subdomains of machine learning, classification, association, cluster, data mining, forecasting, visualization, in order to understand, analyze the actual phenomena with the data. Okay, so let me explain couple of new things here from this particular explanation. So yeah, we know from wide range and varieties of science like mathematics, statistics, information science, computer science. Okay, we can use any concept, we can use any programming language, we can use any algorithm from statistics, we use some theorems from mathematics, we use integral calculus, we use differential calculus from mathematics, we make use of probabilities from statistics and mathematics, we make use of the computer science platforms in order to perform the implement the setup, the environmental setup, right? So basically we make use of many concepts, many theories, tools, technologies from different varieties, from different disciplines of science. Basically everything is science. Okay, but when it comes about data science and machine learning, then we have some specific areas, then we have some in standard, you can say we have some standard type of objectives behind the data science projects, and these objectives are generally like regression analysis, classification analysis, association analysis, cluster analysis. Okay, so basically when we talk about the standard, the common data science and machine learning project objective, we generally try to solve some problem based on these subdomains, based on these standard areas like classification analysis. Let me give you one example of classification analysis to all of you. So what is classification analysis? Classification analysis is nothing but like classifying or dividing the objects or data points into different known classes. Okay, so for example, if you have got some tumor, okay, a tumor or a cell. Okay, so let us talk about some example from healthcare background. Okay, so generally what happens, for example, when a patient visits to some hospital or something related to some problem, maybe because of some pain or something. Okay, and then the doctor's diagnosis, okay, you have some tumor or something. Okay, then that tumor, the sample is taken from that tumor, and that particular sample is analyzed, right, by the experts, by the team of experts, the doctors. Okay, and then based on their analysis, the sample or the tumor is classified into cancer tumor or normal tumor, right? So suppose if we can come up with some machine learning solution, and using that machine learning solution, we can feed the information about that sample or that tumor into the system, and then system can decide, the system can predict if the given sample is a cancer tumor, a cancer cell, or a normal tumor, right? That is an example of classification analysis. And yes, this is being implemented in real world, and we have the machine learning models already working across the globe in healthcare industry, and they are helping to make this type of prediction and makes many advanced level predictions with all the accuracy. So this is just an example like how a data science project generally has some objective. So similarly, we have some a different type of objective, or we have some different type of areas, like we perform regression analysis, you perform association analysis, cluster analysis, forecasting, or time series analysis. Okay, so these all are nothing but different type of data science project objectives. Okay, so let us make a very quick conclusion here. So data science is all about data and science. Data can be present in any format, like structured data, semi-structured data, unstructured data, relational database system, or big data platform, or text files, whatever, but data is data. Then we have science, and science can also be present in any format. It can be a tool, a platform, a programming language, an algorithm. Okay, so when we combine these two things together, in order to extract the knowledge, and order to extract the unobvious knowledge, okay, not the obvious knowledge, the unobvious knowledge, the insights from the data, then that process is known as data science. Okay, so here I would like to complete our first topic, a very important topic. Okay, what is data science? Now we will proceed further with the second topic, the second area, which is also very important for the aspirants, data science aspirants. What do you need to learn? Basically, data science toolkit. So this is a very confusing questions among participants, like exactly what am I supposed to learn? There are too many things available in the market. Okay, I know, okay, now what is data science? I know what is machine learning. Now I want to understand, I want to learn data science. Okay, so someone says you should learn Python, someone says no, you should learn R, someone says you should learn big data, someone says you should learn SAS, MATLAB. So we have plenty of things available. How exactly, firstly, all these things are used in real world, in the real scenario, and what am I supposed to learn? Okay, in order to answer this question, firstly I will let you know, like, data science is not a one step thing. Okay, when we work on a data science project, actually we work on different phases of that project. So data science is not something like you build the model, you make the prediction, and that's it. No, 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 no. So data science is a way more than that. Okay, so a data science project is implemented, is executed in a phase wise manner, and we have multiple phases in that project. The very first phase, you can say, or that the very first phase which starts with the data science project starts with, is like a business understanding phase. Okay, the requirement gathering or the requirement analysis phase. Okay, so like as such, specialized tools or programming languages required for that. That's why I did not put it here, but we will talk about that phase as well. So I have noted down here all the phases which are important from the tool or from the programming language selection point of view. Okay, so some of the very important phases that we have in a standard data science project are data engineering, data analysis, statistical and probability related analysis, analytics and visualization or advanced analytics, then machine learning. And when you work on these different phases of a data science project, you need different tools and programming languages for that. Okay, so what is data engineering? Let us try to understand that first, or we will understand all of them one by one. So starting with the data engineering, what is data engineering? Data engineering in simple word is nothing but from the initial collection of the data to the transformation and finally making the data in the final format. Okay, so it's all about data engineering, data transformation, data processing, so that you can take the raw data from the sources, you can apply the transformation on the raw data, you can make it available in the format so that it can be used for the further analysis or machine learning solution, machine learning model building process. Okay, so that is all about data engineering, data pre-processing or data processing. Okay, so a heavy transformation sometimes required, and generally at enterprise level we use some data transformation, some professional data transformation tools, which are also known as ETL tool: extract, transform and load. So some of you who are already working in ETL on some of the ETL tools like Informatica, Talent, OpenTahoe, Data Stage, right? So you can understand this very well, right? So how an ETL tool is used to, transform the data. It is like extracting the data from different sources, combining them, joining them, merging them, massaging them, okay, transforming it, and then finally loading it into the target data warehouse or a data lake or a relational database system. Okay, that is about the ETL process. Very similarly, in big data environment, when you do not have some relational database system, but rather than you have some data lake, okay, where you load the data in file like HDFS environment. Okay, so there also, we make similar thing. We do the similar thing. We have data engineering there as well. So you extract the data out of data lake or HDFS environment. Sometime we create like hive tables, okay, by applying the transformation logic. So we create some feeds, data feeds, and finally load the data in the form of hive tables, and so that those hive tables can be further used by the data scientists for the further analysis and machine learning model building. Okay, so sometime if you are working in the big data environment, then you will use the big data tools and technologies in relational database system or data warehouse. In the normal data warehouses, we generally use some ETL tool. And in order to work on this particular phase, data engineering phase, the most important programming language that is PL SQL concepts. Okay, so the first expectation from all the data science aspirant is you should be very good with the PL SQL concept. You should know what is the concept behind ETL, how the data is processed, how the data is engineered. So this is something that you should learn even before starting with any programming language, any statistical programming language like Python or R. Okay, so I'm not saying that you should not learn Python or R, but I'm saying that this is a kind of prerequisite. PL SQL concepts are very important, because most of the time you are going to play with the data. If you are good with the PL SQL concepts, if you are good with the ETL concepts, then you will be able to achieve this type of data engineering or data transformation very easily and very efficiently. Okay, let's come to the second part, data analysis. So data analysis is like a very generic task. In data analysis, generally some senior data analyst try to understand the data. Once the data is available, after the data engineering phase, data analyst or data scientist start analyzing that data. What is this data? What different aspects we have about the data? What is the business requirement we have? What business is expecting out of this data? What type of predictions are possible? What type of predictions are not possible? So in order to understand this data very well, data analysts perform different type of analysis. Like they perform exploratory data analysis, they perform descriptive analysis, they perform a statistical analysis, okay, and finally they perform predictive or inferential analysis to answer the questions. So these are some variety, these are some different types of analysis a data scientist generally perform. In order to perform this sort of analysis, you are going to use some statistical programming language. Okay, so from here the here comes the statistical programming language in the picture. And generally nowadays, as like Python is leading the data science or machine learning market. So most of the data scientists nowadays are using Python, and R is also very important player. So most of the data scientists are still using R. Okay, so R is also there in the market. Even some great data scientists still prefer to use R for data analysis rather than Python. But yeah, because of the latest happening, because of the latest advancements are being done in Python, nowadays Python is growing like never. But yes, Python and R both are equally important when it comes about the data analysis. So yes, you need to learn either of them. Okay, not both, but you can learn either Python or R in order to work on data analysis. We also have SAS, but it is like a proprietary tool, so it is not freely available, and that is the reason now it is being outdated. So most of the recent work latest happening, which is happening, okay, that is happening in Python or R. Next comes the statistics and probability. So yeah, most of you must have heard about this. Like statistics and probability is really important for data science, and that is the reason sometimes the people who are not interested in statistics and probability, they think, okay, oh, no, I cannot go ahead and I will not be comfortable with the statistics and probability. Okay, but so let me answer this question very frankly. So see, yes, without statistics and probability knowledge, definitely you will not become a good data scientist. Okay, but it is not like that, that you have to know entire statistics and probability. No, no. So there are some specific areas and concepts of statistics and probability which are required for machine learning and data scientists, not the entire statistics and probability. Okay, second thing is, it is not required, like all the concepts are not required at the initial stage. You should be definitely aware of the basic concepts, like random variables, central tendencies, variance, standard deviation, correlation, hypothesis testing. Okay, so this type of concepts, Bayes theorem, like probabilities. So this type of basic concepts, intermediate level concepts, are definitely required, but the advanced concepts will come in far future, not in very near future. Okay, so it is not like that you will have to firstly complete entire statistics and then you can start. No, no, no. So you can work on both the things simultaneously. You can learn some statistical programming language like Python or R. In parallel, you can also work on statistics and probability, and you can make yourself comfortable with the basic concepts of statistics and probability. Okay, first, before starting with the advanced data science and machine learning. Next comes the analytics and visualization. Okay, so this is about the output part of the data science or machine learning project. When you work on a data science or machine learning project, you work on modeling, you work on predictions, finally you get the predictions, and then you would like to represent your findings, your predictions, in the form of visual analytics, in the form of charts and dashboards. Okay, so yeah, a data scientist should be very good in the visual analytics as well. A data scientist should be very good with the business intelligence concepts. Okay, so you are supposed to work on some dashboards, some charts, some plots, and that's why all the statistical programming language like Python, R, SAS, they provides you a lot of functionalities to draw, to plot different type of charts, plots, visualization, interactive visualization, advanced visualizations. Okay, so analytics and visualization is, yes, really required. If you are not comfortable with some basic plots, like if you do not know what is a bar plot, what is a pie chart, what is a line plot, what is box plot, then make sure you start working on this type of simple plots right away. And in parallel, you can also work on analytics and visualization. So by the time you cover data science and machine learning, you are also good in the analytics and visualization. And I would suggest all of you to learn some visualization tool, at least one visualization tool. So for example, Tableau, you can go ahead and start learning Tableau. It's a very good visualization tool, and it is available, I think, free of cost to download for 1 month or something. Okay, so you can try for 1 month and then you can learn Tableau on your own. It is quite easy. Okay, so you can go through the Tableau official website, and there they have all the tutorials available and everything. But yes, visual analytics is also required. For the visual analytics, for the advanced analytics, if you are working on some statistical tool like Python, R, they have all the visualization libraries to draw different type of plots. But yes, learning a visualization tool like Tableau, ClickView, okay, it is always going to be an added advantage. So I generally suggest this to all the participants. Finally comes the machine learning, the heart, okay, the core part of data science, which is machine learning. Machine learning is what? Machine learning is nothing but using some algorithm, some standard algorithm, some predefined algorithm from statistics and mathematics, and then using those algorithm, we try to answer the prediction problem. Okay, so for example, as I mentioned earlier, the classification problem. So in classification problem, we were trying to classify the cell into normal cell category or normal tumor category or cancer tumor category. In this type of problem, when we are working on some classification solution, we have different type of classification algorithms available. Some of the very famous classification algorithm are k nearest neighbor algorithm. For example, it is a classification algorithm. Then we have support vector machine or support vector classifier. We have decision tree. We have logistic regression for binary classification. We have random forest, like ensemble learning method of decision tree. So we have naive bayes. So we have different classification algorithms available. So when we work on machine learning, actually we do not invent something new. Okay, we have these predefined standard algorithms available. We work on some statistical tool like Python or R. Using Python or R, we select a particular algorithm. Like for this problem, let us assume we have selected uh, k nearest neighbor. Okay, so we select a particular algorithm and then we implement that algorithm in Python, okay, on our data. And that process, when you combine an algorithm on your data along with your data, when you use an algorithm on your data, that becomes a machine learning model. So machine learning model is nothing but the combination of some standard algorithm, predefined algorithm, and your data. That becomes a machine learning model. And how do you build the machine learning models? You build the machine learning models on a statistical tool like Python and R. So that is why you have to learn Python and R if you are going to work on machine learning. So any one tool will be sufficient. Apart from these open source tools like Python and R, and SAS is also there, but Python and R, we have some integrated development environments designed by some very big organizations like Microsoft. Microsoft has built a Microsoft Azure Machine Learning Studio, IBM SPSS, SAP Predictive Analytics. So these are some integrated development environments are also there, using which you don't need to work on the core language like Python and R, and rather than you can directly work on some GUI based environment and you can still work on machine learning. But I would say that is more implementation part, that is more sort of deployment part. When you want to learn something, you will have to get your hands dirty with some programming languages like Python and R. Without understanding the core concept, like working on Microsoft Azure, ML Studio, or SAP Predictive Analytics, that is quite handy, that is quite easy. Okay, but if you do not know what is happening behind the scene, you will be helpless. Okay, so that's why learning some open source programming language and making yourself comfortable with model building using Python and R, that is challenging. That is something which is highly recommended. That is something which is very much expected. Okay, so having said that, these are different things. These are different phases that you generally work on while working on a data science or machine learning project. So you have to have working knowledge of, you have to have expertise knowledge on some statistical programming language like Python or R. And as you can see, in most of the phases you can use Python and R. You can use Python and R for data engineering, for data analysis, for statistical analysis, for visualization, for machine learning. That's why everyone is saying learn R, learn Python. Okay, because these programming languages can be used for all of these purpose. Okay, apart from that, the conclusion is you have to learn some statistical language like Python and R. Apart from that, you have to learn PL/SQL concept, very important part. Then you will have to also learn some visualization and analytics, and then you will have to learn some algorithms for machine learning. This is the minimum package. This is the, you can say, prerequisite, not prerequisite. This is the this is something that you will have to learn, at minimum, if you want to get into data science or machine learning. And this is something which is expected from a beginner to start working on when you are working on when you want to get into data science or machine learning. Okay, apart from all these technical stuffs, definitely one should have some business or domain knowledge as well. Okay, so like in data science, generally what happens, you work for some clients organization. These clients organizations can work in healthcare domain, they can work in aviation, they can work in banking and finance domain, so they can work in different domain. If you are good in a particular domain, like suppose you are very good in banking and finance, you are very good in healthcare, you are very good in aviation, then they will not have to teach you the business. You already know the business and you are a data scientist, then it's like half work is already done. They don't need to explain you what our business is. You already know that business. That's why having some good knowledge of business or domain will definitely help you. But learning business knowledge or having the domain knowledge is not something that you can learn from the books, from the trainings. Okay, this is something that you will gradually get when you actually work on the real world projects. Then you get the business knowledge, then you get the domain knowledge. So make sure, like in whatever industry, in whatever domain you are working on, make sure you are understanding that domain, make sure you are getting that domain. If there are some functional terms, the business terms which are used by the users, the end users, make sure you ask questions, but you understand the meaning behind that. Okay, so don't be try to be fully technical. A data scientist is someone who understands the business very well. So a data scientist is a techno functional person, okay, who is very good in the functional and the business concepts as well. Okay, and here I would like to conclude this second topic, and let me see what questions I have so far on the first two topics, the data science and the data science toolkit. Okay, so I'm expecting a lot of questions. Let me see how many questions I can answer effectively. Okay, so okay, bear with me. So I will try to answer these questions one by one. Is there standard BI models for service management? So we are our scope is limited to data science. I request you to ask the questions from the scope only. Okay, all the PPT and recording related questions I'm not going to cover for the time being. Okay, what are the career prospects in data science and what are the skills? So I think we have already talked about the skills. Okay, and let us talk about the career perspective. Okay, so in data science and machine learning, it is not like the only opportunity we have is data scientist role. No, so a data science is a whole project, a whole new world area, you can say. And when we work on a data science project, we need people expertise in different area, because as I mentioned earlier, in data science we work on different phases. So we need someone who are good in data engineering, we need ETL developers as well, we need big data engineers as well, we need PL/SQL developers as well. So if you are good in all these things, you still have a chance to get into data science as data science engineer role. Okay, at data engineer role in short. So you still have the opportunity in data science as data engineer. Then we have data analyst role. So you don't know anything about data science and machine learning, but you are a very good data analyst. You have plenty of experience, like at least more than 5 years of experience in business intelligence, in data analysis, in ETL, data warehouse, data modeling. Then you understand the data very well, then you can be a part of data science project or data science group as a data analyst. And so we have data analyst jobs available in data science project. Then we have visualization expert role available. So a data science project also needs those people who are good in visualization, dashboard development, plots, charts. So if you are good in some visualization tool like Tableau, ClickView, Spotfire, business objects, even the packages available with Python and R like ggplot2, matplotlib, plotly, seaborn. So these are some packages available in Python and R. So if you are good in this type of visualization part, and then you have a chance to get into data science or machine learning project as data science as visualization expert or analytics expert. Okay, then we have machine learning. So those who are from mathematics background, like you are master of statistics, you are master of mathematics, and you are very good with the algorithms, you are very good with Python programming, R programming, statistical tool. You have worked on a statistical tool to implement the machine learning model. So you are mainly you have mainly worked in you have mainly played with the algorithms, you have mainly played with the machine learning models. As of now you are very good in statistical analysis, so you stand a chance to be to apply or to get into data science project as a machine learning expert. Okay, so we also have machine learning expert role where we need people who are very good with the statistics concept, with the machine learning concept, with the algorithms, and they know how these algorithms are implemented in different platforms and different using different programming languages like Python and R. Okay, so data science is not about like data scientist position, but you have data engineer, data analyst, dashboard expert, machine learning engineer. Okay, so all these roles are also available for you. Okay, and then Gautam is asking, I am a fresher. What are the best platform to learn data science? So as a fresher, I have already talked about what different things that you need to learn, Gautam. But if you have mentioned what platform you need to learn data science. So basically, there are a lot of trainings, there are a lot of courses available nowadays online. You can select these courses. Cognixia is also providing some instructor led live courses, so if you are interested, you are more than welcome to inquire about the courses Cognixia is offering, and definitely uh, you can get advantage of it. Okay, and let me see more questions. Okay, so someone is asking, what is difference between big data and data science? So see, big data is nothing but an environment, the platform using which you manage, using which you store, using which you retrieve the data present in the form of big data. So basically, um, uh, uh, a synonym to big data nowadays is Hadoop, right? So what is Hadoop. So Hadoop is a big data platform, and using Hadoop, the data is stored in the form of data files, not as relational database tables. Okay, so it's like storing the data in the form of files, and basically HDFS is there, Hadoop distributed file system is there behind Hadoop. So basically, big data is all about the data management, the data storage, the data retrieval in a big data environment on a big data platform like Hadoop. But data science is actually utilizing this data present in big data environment or present in a normal data warehouse environment in order to answer the business specific question, in order to make the prediction about the data in future. So that is data science. Okay, so that is the difference between data science and big data. And what is the difference between data science and data analysis? So the same difference that I have mentioned between data science and business intelligence. Okay, so business intelligence is all about data analysis, so that same difference we have between data science and data analysis. Okay, what is the role of SQL in data science? So basically, as I mentioned earlier, SQL or PL/SQL is very important concept, a very important ingredient that you need in order to work on data science or machine learning project. Because when you have the data, you retrieve data from different sources, you get the data from different sources, and finally you make the data available at one place, generally in the form of relational database system. Even if you are working in on big data platforms, you make the data available in the form of like Hive table. Okay, so SQL is nothing but like a structured query language, is very important in order to analyze that data, in order to understand actually what is present in the data, how the data is present, at what granularity the data is present, what each and every record is representing in the data. So having the PL/SQL knowledge will help you to understand your data better, and also having the PL/SQL SQL knowledge will help you to apply the transformation logic on your data. So not the raw data is generally used for machine learning or data science analysis purpose. You process this data a lot, transform that data a lot, and then only you make your data available in the format so that it can be utilized for machine learning or data analysis purpose. Okay, so that is where SQL is important. Okay, then I'm a researcher in geochemistry. I want to know how data science helps in the field of geology or geochemistry. Okay, so I'm not that much expert of this particular domain, but nowadays in a lot in a lot of in a lot of areas from geology, chemistry, data science is being utilized to understand the atomic level properties and behavior of the materials. Okay, so that is somewhere in the life science as well we are using the data science, the relationship between the different components, different ingredients of you can say the medicines, and you can say the particles. I'm not a expert of this particular area, so I would not be able to answer this question with all the expertise. But yes, data science has got some standard models, standard areas, as I mentioned earlier. So whenever if you are working on some sort of like problem related to like classification, related to understand the relationship, if you want to make about some predictions, definitely you should be having some data available, right? Where it is going to be domain independent, whether you are from geochemistry, whether you are from geology, whether you are from aeronautics or whatever, but you are going to have some data, right? And when you have the data, you can make use of that data to solve some problems related to the relationship, related to the predictions. So in that way, in all the domains, in all the areas, data science is helping the world. Okay, data science is a process, not an event. It is used to understand things and understand world. Yeah, Wasim. So you are quite correct. So different people defines data science in different way, and definitely all the definitions are correct. Like some definitions are more accurate, some definitions are accepted by more people. Okay, but different peoples have different thoughts on these definitions. Okay, how data science is different from machine learning? So basically data science is a super class, you can say, and machine learning is a subclass, a subset within data science. So when we talk about data science, actually we may or we may not work on machine learning problems always. Okay, data science can also be some descriptive analysis about the problem, where you will not use any machine learning solution, rather than you perform some statistical analysis, rather than you will perform some exploratory data analysis. So that is also something which comes under data science. But sometimes, or most of the time, you make use of machine learning and then you perform the predictive analytics. Okay, so that's how data science is different from machine learning. Okay, so we are not going to cover any topic like machine learning or something in detail here, that is beyond the scope. Okay, someone is asking what is the difference between classification and prediction. So maybe you want to know what is the difference between classification and forecasting. So when we say prediction, the more accurate word is forecasting. So classification is about making prediction about the class. Okay, like this object or this particular cell should be a cancer cell or a normal cell. But forecasting is about forecasting something in future, like based on last 4 years revenue, based on like last 4 years sales information. If we want to predict the sales information, the sales or the revenue in next quarter, in next month, then that is about the forecasting. Okay, I have already explained the difference between data science and machine learning. Yeah, I'm replying the questions. Okay, so I'm going through one by one. Okay, what is ETL? So ETL is extract, transform, and load. It is the process, the standard name, which is used to apply data engineering or data transformation. So your data can be present in different sources. Your data can be present in the files. Your data can be present in relational database system. Your data can be present in any other format. With the help of ETL, you extract the data from different sources. You apply some transformation logic, like you merge the data, you join the data, you aggregate the data, and then you load that data in some target database system like data warehouse, like data lake. So that process is known as ETL: extract, transform, and load. I'm sorry, I didn't answer your questions earlier. So yeah, I'm answering now. What is the difference between data warehouse and big data? So basically, generally, data warehouse, when we use the word data warehouse, we use this term for the data inventory, which is implemented at the top of relational database system. So generally, data warehouses are implemented in Oracle, on SQL Server, so like relational database systems. Okay, but when we talk about data lake, or when we talk about big data platforms, so in big data platforms we don't implement data warehouse, we call them data lake. We implement data lake with the help of big data platforms. So that is the technical difference between the data warehouse and data lake, or data warehouse and big data environment. Which is important, Python and R? So see, both are important, Python and R. The question is what we should learn, Python or R? So I would suggest nowadays, considering the growth, considering the demand in the market, it's better to learn Python. Name of the probability area. So yeah, there are many concepts from probability, like we have Bayes theorem, we have normal probability concepts, then like it's all about there is a very thin line between statistics and probability. So all the concepts from statistics are associated somehow with the probability as well, but all the basic probability related concepts like probability distribution, normal distribution, standard normal distribution, continuous and discrete probability distribution. Okay, all these are very important, like hypothesis testing, p-value, area under the curve analysis. These are some important concepts one should be aware of. For data science, definitely, particularly for data science, I would say R is better for data science analysis purpose. But when it comes about the implementation part or deployment part, then Python provides you more option. Is data science same as data analytics? No, data science is not same as data analytics. Data analytics or data analysis is a sub part of data science. In general, which area we should learn, anyone or all of them? So you need to learn all of them for sure, but you can follow an approach, like you can start with some PL/SQL concept and start learning some statistical programming language like Python or R first. Okay, so start with these two, like firstly learn PL/SQL and Python programming, and then gradually you will learn the visualization using Python. Then you can learn some visualization tool like Tableau. Then you will learn some machine learning algorithm and how machine learning is implemented in Python. So firstly learn some programming language like Python, and then you can proceed further. What is ETL? I have already explained it. Python, or someone is saying that Python is very slow, so very often in automotive, C++ is preferred. So it's about the environment, I would say, Adam. I have worked on Python in at enterprise level, and if your environment is good, if your like a server is good enough, then you will never face any such problem related to performance or something. And if you have really huge data, then you can go ahead with a Spark as well. So Spark is the answer when it comes about the huge amount of data and you want to implement some machine learning using that data. Then I would say even Spark will be even better as compared to any other programming language. Okay, so I have already, please tell us what we have to study minimum. So I have already shared this minimum. At minimum, you need to know the PL/SQL concept. You need to know at least one statistical programming language. You need to you have to be comfortable with programming concepts using Python or R, and then you have to learn some of the standard algorithms, machine learning algorithms available in order to get into data science. These are three, and visualization as well. These are the four minimum things. Someone who is not from development background, how difficult is to learn Python and R, what are the sources available to learn them? So let's see, learning Python and R is not that much difficult nowadays because both the languages are available in interactive mode. And like IDs that we have, like for R, we have RStudio. For Python, we have a Spider, PyCharm, Jupyter Notebook. These IDs are very, very user friendly. So any beginner can start working on or start learning Python and R very easily without facing any problem. It's not like other programming languages like C, C++, Java, where you have to write an entire program in order to get the output. Okay, these are very user friendly languages. For beginner from non-technical background, which tool is good to begin? I would say for beginner, uh, 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 like I see, it's not about like beginner or something. If you are really serious to get into data science and machine learning, I would say start with Python itself. Okay, Python is very easy. You will start at beginner level. You will learn the beginner level Python first, and then gradually you will make further progress. So don't get into all the advanced things like machine learning from the starting itself. Firstly, make yourself comfortable with Python programming. Is it possible to combine multiple programming languages to achieve the objective? Yes, Vaibhav, it is possible, but generally it is not required. Like unnecessary, if it is not required, then we cannot do that. But yes, what you can do actually, you can have a kind of batch scheduling or batch processing where one script is doing, like one Python script is taking care of one part, then you are giving the output to some R script, then remaining part is done by R script, then some ETL tool, then by some SAS. So you can definitely do that. But if one programming language is sufficient to perform all these things, then why we should go ahead and use multiple things at a time? So how can students get the industrial knowledge? So you can read the books on industrial, on the domain knowledge. That is the only way. You will have to study these things. You can get enrolled to some courses, like if you are interested in the businesses, in particular BFSI or something, you can go ahead for MBA. So these are the way generally students get business and domain knowledge. Is one language is sufficient, like Python or R? Yes, yes, definitely. At the beginner level, at the intermediate level, yes, one language is sufficient. But when you will start working in some enterprise as a data scientist, as a data analyst, you might end up with working multiple programming languages, working on multiple programming languages, because sometime we work on one project for one client, and their environment is different. You work on different programming language, then you work on another project, there another programming language is used. So sometime eventually you become expert in all the programming languages. But yes, at the beginner level, just one language like Python is more than sufficient. How Amazon AWS be used in data science? A very good question, Priyabarta. So like nowadays what is happening, all the latest things which are happening, which are taking place nowadays, whether it is about machine learning or data science or any other word, but the solutions are being hosted on cloud. And what is AWS? AWS is nothing but a cloud computing solution. Okay, so you can also host your machine learning models on AWS, and then you don't need to worry about your infrastructure. So the small organizations who do not want to pay for the infrastructure, they do not want to have the on-prem infrastructure, they buy generally cloud services like AWS, and there they can perform their data science analysis or machine learning analysis by deploying the model on cloud rather than having the machine learning or data science model on-prem. What is about deep learning versus machine learning? So yeah, good question. Machine learning is about mainly about the structured data. So when you have the structured data and you use the standard algorithms available from statistics and mathematics, and you try to implement those algorithms with the help of statistical programming language like Python, it is machine learning. Okay, when you have, like, you can further have supervised or unsupervised type of machine learning, which is another topic, another area altogether. But when we talk about the unstructured data, when we talk about image data, sound, the voice, the video, okay, so when your information is present in this type of format where you cannot use the traditional machine learning, then you use deep learning, you use neural network, you use different type of neural network in order to make the prediction, in order to make the decision about this type of unstructured data. That is known as deep learning. Yes, data scientist is also responsible for all sort of analysis, requirement gathering, business understanding. Okay, someone is asking, I'm a SaaS practitioner, and as per you, its future is not bright. Is it so? As most of the banks are using. No, no, I didn't say that. So Abhishek, I didn't mean that at all. So please don't take it like that. I didn't say that. SaaS future is not bright. I'm saying that with the latest happening in the market, open source technologies and open source tools like Python mainly is having all the latest happening in the fields of deep learning, reinforcement learning, all the new models, all the new things which are taking place in the market. The APIs, the libraries are getting released in the for the open source tools first, okay, as compared to some proprietary tool like SAS. But SAS is the leader in the analytics so far, right? It has been leader from quite a long time in the fields of data science and machine learning. But yes, because it is a proprietary tool, so the small organizations or the organizations which are not willingly they are not willingly do not want to willingly spend on this type of analysis or advanced analytics or data science or machine learning projects. They are actually more inclined towards the open source tool, where they don't need to pay for the for purchasing the tools for the programming languages. So that's the reason, the new player in the market or the new organizations who want to work in the fields of data science and machine learning, they are giving preference to open source tool like Python and R, because they do not want to pay at least for the tools and languages. Okay, so I already mentioned the difference between machine learning and deep learning. Okay, so ETL. Okay, so I'm skipping these questions which I have already covered. Okay, so sorry, like the scope of this particular webinar does not you know cover the talking about does not cover different areas like cluster analysis or segmentation analysis or regression analysis. Okay, so I can explain all these things, but due to the time limitation and due to the scope limitation, I would not be able to answer this type of question. Okay, I'm a SAS guy. I can learn advanced analytics in SAS, or I need to learn R. No, I would R or Python. I would say if you're already working in R, you should be quite comfortable with all these concepts. But yes, having the working knowledge of some open source tool like R or Python is always going to give you some added advantage. So Sapnil, I will definitely suggest you to, in parallel, start implementing your knowledge, start implementing all these machine learning models or data science things in Python, I would say. Okay, that is going to be beneficial for you. Okay, is ETL, PL/SQL, and Python is enough for entering into data science? Yes. So ETL, PL/SQL, Python, and a little bit of visualization is going to be more than sufficient for at entry level. What is the duration of typical data science project? Yeah, data science projects are generally going to be short duration project, and it can last for anywhere between like 2 to 3 months to 1 year generally. No, you don't need to learn, all the programming language like R, Python, SAS, everything. I would say nowadays it is better option to go ahead and learn any one programming language, and maybe Python is the better option. So go ahead with Python itself. So there are many opportunities available at all experience levels. So all the folks who are asking about, like, I am having this experience, I am having that experience. So yeah, for all, like, if you are having like less than 1 year experience, if you are fresher, if you are more than 5 years experience, you are 10 years experience. So we have different roles, like for the entry level, or for the folks who are having less than 2 years of experience, you can opt for some role like data engineer. Folks who are having more than 5 years of experience can go ahead with data analyst role. If you are having like more than 8, more than 9, 10 years experience, then senior data analyst or data scientist can be the role that you can opt for in future after learning data science and machine learning. How do you decide which algorithm is used for machine learning model? As explained by you, we have different algorithm like KNN. So yeah, actually, this is decided based on the data. This is decided what you want to predict. This is also decided your target variable. If your target variable is continuous random variable, is continuous in nature, it's categorical in nature. So based on different thing, and in a type of input features. So based on different thing, this decision is taken. It is not that much straightforward to answer. Okay, that's a typical question of machine learning. What is the use of Jupyter Notebook in data science? Jupyter Notebook, with the help of Jupyter Notebook, you can actually execute Python or R code. So basically, it's a very good, you can say, platform to learn the statistical programming language like R and Python. It is used as the IDE for by the data scientist to perform the independent analysis, because it provides interactive way to work on some programming language like Python and R. Like you give input and you get the output, so it's very interactive. Okay, for all the course related questions, what is going to be the duration of the course, eligibility or everything, I would request all of you to please get in touch with the Cognixia support team, and they are going to be more than happy to assist you for all these things. Okay, and so friends, I think we are getting out of time, and I know we have many more questions asked by all of you. I'm really sorry, but I cannot go ahead and answer all the questions. So let us go ahead and start with the next concept, and maybe all of your questions will be answered automatically in the next slides, in the upcoming slides. So without wasting our time, we can go ahead and start with the next topics, so that we can finish this webinar in time and we can cover all the topics. Okay, so I hope you will understand, and I will try to again go back to your questions and answer the remaining questions if possible. So now the next thing that we are going to start is the data science project life cycle, and now we will try to understand, like in real world, how the data science project is implemented. We have already talked about some important phases of data science project life cycle, and now we are going to talk about this very famous crisp dm process model. So crisp dm process model was invented like in 1996, and at that point in time, the challenge was something like that. Different organizations were using different approaches to work on data mining or data science project. So there were no standards available, there were no common approach available to implement a data science or a machine learning project end to end. So there was the requirement to come up with some standard approach, so this model was invented. Now we are going to talk about all the different phases that this particular model suggests, and according to this model, there can be 1, 2, 3, 4, 5, 6 different phases in a typical data science or machine learning project. Again, these phases are not mandatory, but in a standard data science project, generally the entire life cycle is divided into these 6 phases. But again, based on your requirement, based on the situation, based on the environment, there can be less or more number of phases, but these are the typical standard phases you can have in your data science project. So the very first phase is the business understanding phase, and the business understanding phase is nothing but understanding your business better, understanding the problem statement, understanding the project objective from business point of view, like what is business pain area and what business is looking for. So maybe, like, business is looking for some predictive solution to predict to make the prediction about its revenue in next quarter. Okay, so you will have to understand what is revenue. Okay, how the revenue is being generated for that particular organization, which particular important factors are responsible for generating higher or lower revenue. So as a data scientist, you will understand all these problem, all these important links of revenue with different things. You will try to understand this particular problem, this particular project objective from business point of view. So you will make, in short, you will make yourself comfortable with the business, and you will try to understand the business objective from business point of view, what business is looking for. Then comes the data understanding phase. Data understanding phase talks about the understanding problem statement or understanding the project objective from data point of view. Little bit technical now. Okay, so now after understanding the project objective from business point of view, you switch to data, and then what you do, you analyze the data, you collect the data, you make yourself comfortable with the data which is available. Then you make the decision what exactly is business looking for from technical point of view. Like, I have to make the prediction about the revenue. So do I have sales information available for my organization or not? Do I have margin related information available? Do I have products information available? Which particular product contributes more toward the business? So we have product data available? Do we have reason information available? Do we have retailer information available? So all this type of data, now you will start understanding, now you will start analyzing all this data which is available, and you will understand the business problem from data point of view. Third comes the data preparation. Okay, so data preparation is nothing but the typical data engineering phase of data science project. When you know what business is looking for, and when you know what input is available in the form of data, then you select that raw data, then you select that input information, you combine them, you merge them, you aggregate all this information, and then you start applying the transformation logic on this data in order to make this data available in the format so that it can be utilized by the data analyst, by the data scientist to further perform the analysis on it, or to use the machine, or to build the machine learning model on this particular data. So that is nothing but data preparation. When you work on data preparation, you work on different type of data transformation, like you join the data together, you merge the data together, you perform the data aggregation, you perform the data cleaning operation, you perform the data massaging operation, you take care of the null data, you take care of the redundant record, duplicate record. So all this type of data transformation which is done with the help of some PL SQL type of utility like ETL process in big data environment, data processing feeds. So with the help of this type of utilities, you transform your data, you prepare your data, and finally you come up with an integrated single big table, or a single view, a single file which has all the required column, all the required fields about your data at required granularity. Okay, so that is nothing but the data preparation or data engineering phase. Then comes the fourth phase, which is the modeling phase. This modeling phase is not about the traditional data modeling that we generally do in data warehouse project or in application development project. Data modeling, here the modeling is machine learning modeling. So once your data is available in the format, in the required format, then you work on machine learning model part. As I mentioned earlier, you simply select a particular algorithm. If you are working on, for example, classification problem, you will select a particular classification algorithm. If you are working on some forecasting problem, you will select a particular forecasting algorithm. You can select like autoregressive model for forecasting, you can select moving average model, ARIMA model. Okay, so this type of different models are available for different type of analysis and different type of objective. Then after selecting a particular algorithm, you combine that algorithm with the data, and that sorry and that actually represents the model. So that is the modeling phase here, making the selection of the most relevant algorithm, most effective algorithm, and then implementing that algorithm at the top of your data. That is nothing but modeling. Then comes the evaluation phase. Evaluation phase can be understood like a testing, or system integration testing phase in a regular software development lifecycle project lifecycle. So here, after building the model or after building the models, we perform the evaluation of the model, like if the model is making the required prediction according to the business expectation or not. Okay, if our model is efficient, if our model is making accurate prediction. If we have more than one model, generally we evaluate, we have multiple models, and we evaluate, we compare those models, and we select one of the best model out of all the n number of model. So evaluation is all about evaluating the model and making the final selection of the model, and making sure your model is generating what business is looking for. Finally comes the deployment phase, and the deployment phase is all about deploying your machine learning model in production environment. Okay, so basically, once you have trained your model, once you have built your model, evaluated your model, then your model is ready to be deployed in production. And then the latest data, the live data which is coming through your organization, can be feed to your machine learning model, so that your machine learning model can make the further prediction about the future. So that process of starting, that process of using your model to make the future prediction is nothing but the deployment. Not all the machine learning models are deployed, and basically, depending on the situation, sometime machine learning models are created for one time analysis, and sometime machine learning models are expected to be deployed in production and make continuous prediction over the period of time. So sometime we deploy the model, sometime we do not deploy the model. So that's why deployment phase is optional in some cases. Okay, so here I would like to conclude our data science project lifecycle according to crisp DM model. And now we are going to start with the very interesting and the very important area for today's webinar, and basically it is about the case study. And this case study is about the Uber Eats application. I hope all of you must be aware of this particular application, Uber Eats application. And the particular use case that we are interested in here is making prediction about the estimated time of delivery. Okay, so as you can see on my screen, this is how Uber Eats application look like. So using this, you can put your orders for the food, and then as soon as you make the order, it gives you an estimated delivery time. So as you can see over there, okay, so as soon as you make the order, it gives you some estimated delivery time, like your food is going to be delivered to you in next 35 to 45 minutes. Okay, so at certain level of precision, they make best possible prediction to to give you an estimated time of arrival, estimated time of delivery. Okay, so we want to understand how this particular prediction is done by this particular application. Okay, so this is the objective of this particular case study. We will understand how Uber Eats is making this prediction about the estimated time of delivery, because explaining or predicting the estimated type of delivery, estimated time of delivery is not that much easy, because it depends on too many things. What particular type of food you are ordering? Some food or some dishes are kind of ready made, they are readily available, while some food and some dishes are going to take too much time to be prepared. Okay, some restaurants can be very near to your house, and some restaurants can be very far from your house. Some restaurants are very efficient in preparing and delivering the food. Some restaurants can be little lazy when it comes about the preparation and delivery. Okay, so there can be n number of factors, and there can be some dynamic factors as well, like the day on which you are making this order can be a rainy day. Okay, and because of the rainy day, the delivery can be little. So there can be high traffic time. Maybe you have ordered something in peak traffic hours, so at that particular time window, generally the traffic is used, and then due to that your delivery is going to be delayed. So there can be n number of static reasons, there can be a number of dynamic reason, but this particular application is making very accurate prediction. This particular application is giving you very accurate estimation about the delivery. So let us try to understand what magic is going on, how they are using the machine learning and data science behind the scene in order to come up with this estimated time of delivery. Okay, so this is all about the use case. I'm going further, and now I'm sharing the big picture in front of you. Okay, so this is the end-to-end process flow of the machine learning solution working in place behind the Uber Eats application, and not for this particular use case basically, but this particular model or this particular flow is used for n number of different type of predictions they are doing. Basically this is the flow chart of the process of the system that they call Michelangelo. Okay, so they have prepared a platform, they have prepared an architecture and an environment using which the data scientists working at Uber can use this platform and work on different type of prediction model. They call this particular platform as Michelangelo. Okay, so we will talk about this entire flow. At this particular level, I know it will be very hard for all of you to understand what exactly is going on, but forget about everything in this gray box. Let us talk about the top. In the top, what is in the heading, what is given over here. Okay, so you will find that this particular model is also based on the same machine learning project lifecycle or data science project lifecycle crisp DM model we have just talked about. Okay, so it starts with get data. Okay, getting the data collection, then it goes to train the model, evaluate the model, and deploy the model, and making the prediction and monitoring. Okay, so it is also following almost same path, almost same flow when it comes about getting the data, building the model, evaluating the model, and finally deploying the model or making the production. Okay, now we are going to talk about all these phases one by one, and we will see what is happening in each and every phase and how the things are making progress. Okay, so let us go ahead and start with the very first phase here, and that is actually getting the data. Okay, so basically this particular activity at high level can be described as data management. Okay, how the data management is being done for this particular data science or machine learning case study. So what Uber has is they have divided, or they have broken their data flow or data pipeline in two parts. One is the online and another one is the offline. Okay, so why two, that you will learn very well in the upcoming slides. But basically they have a distinction between the online data flow and the offline data flow. And because the particular use case of machine learning model we are interested in is a kind of online use case where we want to make the real time predictions, so our focus is going to be this particular pipeline where they are making use of the live data and they are making the live connection. Now let us try to understand how this offline pipeline is also very important, or is also supporting actually this online flow of the data. So basically here they have their data lake, and their data lake is making use of basically it is a big data environment. So they have like a Spark infrastructure. They have their data, all their customer data, restaurant data available in the data lake. From the data lake, they are performing the data engineering or data preparation stuff here with the help of a Spark. So like we have Python, R, we also have a Spark, which is generally preferred nowadays for big data platform. So they are making use of a Spark in order to perform the data engineering or data preparation phase. And then after the data engineering and data preparation phase, they are actually storing two type of information. The one information is the feature information. Feature information is all about the input feature or independent variables related information about their restaurant and their client, that they call this particular space as the feature store. And that feature store is nothing but the Hive tables. In Hive, basically they store all these features in the form of tables, Hive tables. Okay, what these features are, these features are mainly about the restaurant, and these features are mainly about the customers who are making the orders. So for example, if I am making any order for using the Uber Eats, then my information like my physical location can be present here, my geographical location can be present here, my demographic related information, my gender, my age. So this type of user level information is available here, my address, on which particular floor I am living. So all this type of information which can contribute toward the estimation of the delivery time is available here. Then when you talk about the restaurants, then about the restaurants, they have all information, the geography information of the restaurant. They have what different foods this particular restaurant is offering, what is the average time of preparation for different food. Okay, so that information is also available, and that is very important feature to calculate the estimated time of delivery. Okay, so in short, all the static information which generally do not change over the period of time or over the small interval of time, all this type of information is stored in this feature store, and that is calculated, that is computed using the historical data, using the historical order information. So over the period of time, this type of models become more and more accurate. What is this outcome? Basically, outcome is actually the training set, okay, on which your machine learning model is trained. So basically, on the day one itself, you cannot start making this type of prediction. Maybe when the Uber Eats have introduced their app, from the day one itself, they did not provide this type of option to show you estimated time of delivery. It happens over the period of time. So what they have done actually over the period of time, they have collected this type of information, like what is the delivery time for the last 6 months for different type of food, for different type of restaurants to different customer in different area, different region, different country, different cities. Okay, so they have built their data set in past, and then using that data set they have collected this information, not only input feature, but they also collected the outcome, the historical delivery times, so that when you have the outcome available, then only you can train your model. Like if this type of situation is happening, like customer is making the order at from place A, and he is making order of food B, and he is making this order from a particular restaurant C on this particular day, on at that particular time, and and some blah blah particular weather situation. Okay, so considering all these type of situation, what was the delivery time? So that is the outcome which is present here. And then once they have enough information available about the feature and about the outcome, they can train the model on this outcome data and the feature data. Okay, so that is why this offline pipeline is also very important in our use case, because this particular feature stores very important features about customer and the restaurants and the food items. Okay, so what happens basically when a particular customer is making the order, all this information cannot be calculated dynamically, but what happens, they fetch all the readily available information, all the readily available features from the feature store to the Cassandra feature store. It is the Hive feature store. All these features are available in Hive tables, in the form of Hive tables. Then for the real-time predictions, these features or the selected features are taken into the Cassandra platform, and the features are made available for the real-time prediction. So this is all about managing the data and using the data. Now let us proceed further and talk about the next phase, which is the model training phase. What is model training? So as I mentioned earlier, once you have all the important features available and you have outcomes as well available, like what was the delivery time last time for this customer and that restaurant for this particular food at that particular time, something like that, right? So when you have all this type of information available, models are always trained in offline mode. Models never trained in real time manner. Models are never trained in in a live environment. Okay, so that is why model training is not present here. Model training entirely present in this second pipeline, which is the offline pipeline. Okay, so here actually the model trained using the historical data of the outcome and the feature information we have about our customers and the restaurants and the food. Okay, having this type of information, input feature and the output column, output feature, the target variable, this is the minimum thing that you need to train a model on. Okay, so we need independent variables or input feature, and we need target variable or outcome to train the model. Once we have these two information, they train the model in a batch training mode. What is batch training mode? So basically, they trigger the loads, they trigger the training by collecting a particular batch data set at a time. They train the model, they pick up one training algorithm, model algorithm, they feed the data into the training algorithm, and they train the model. They not only train just one model, they actually train multiple model. Okay, there can be n number of model for the same use case. All the n number of model after the training phase are stored into a model repository. What is a model repository? Model repository is nothing but a place where all the trained model are stored after the training. Okay, so initially we train the model, and then once the training is completed, all the trained model are stored in the model repository, which in case of Uber Eats is a Cassandra platform. So there all the trained model are stored, so that in future these trained model can be used for making the prediction. Then comes the model evaluation phase. What is model evaluation phase? Basically, in order to evaluate your model, in order to make sure that your model is making correct prediction or not, if your model is efficient or not, you perform model evaluation. And how do you perform model evaluation? Using the outcome data, using the labeled data. So you have historical data available. You use some portion of the historical data for your model training purpose, and the remaining portion or another set of you can say the historical data to evaluate your model, to test your model. Also you perform model cross validation. You compare the different models together, which particular model is making better prediction. It is possible that for one model you can have a very good accuracy, for another model you can have average accuracy, for another model you can have poor accuracy. So this type of things are also done in this particular phase. You build a number of models and you evaluate the models, you compare the model, and finally you make the selection of the best model for the given use case. So all these things, how these things take place in this particular phase, evaluate the model or evaluate the models. Once your model is trained, once your model is selected, then you deploy the model. Now there are two types of deployment: online deployment and offline deployment. Now so far we have been mainly working on a single pipeline in the offline mode, in the batch mode, where we have trained the model in the offline mode. But once the models are trained, you can utilize those models for online prediction and offline prediction. That's why models are deployed in online platform, on online platform, and offline platform. Basically it is nothing but the platform only. Okay, in order to make the real-time prediction, your model which are supposed to make the prediction in real time are deployed on online container. On online container is nothing but a framework or a platform where you get the live data from the customer and you make the live prediction at the same time by accessing the model repository. So basically the trend model, the selected trend model is sent here to the online model container, and there the model reside, and it is responsible to make the online and real-time prediction. Very similarly, in the model offline mode, we have offline model container. The offline model container is going to have the trend, selected trend model, and these models are supposed to make the prediction when a particular data scientist or a particular scheduled processing is triggering this job. Okay, so then only, generally in the batch processing or at a given schedule, these predictions are made. And these are, some internal type of prediction. These are generally the offline predictions, are not predictions which are utilized by the end user. These are those predictions which are utilized by organization, by the data scientist. Okay, maybe like which particular area is going to earn more revenue for us, which particular restaurant is going to make more revenue for us in the upcoming weekend, or something like that. Okay, more related to the business type of predictions. Okay, while the all the real time predictions are mainly going to the user related predictions, where the users are going to utilize these predictions, like when my meal will arrive. Okay, so estimated time of delivery is an example of online and real time prediction. So for our use case, for this particular use case, we are going to make use of the real time prediction or online prediction. So that is how models are deployed. And finally, we come at the step where we make the predictions. Okay, so how do we make the predictions? Once our model is deployed in the online container, online model container, then we select or we fetch the input information about the customer, about the restaurant from the Cassandra feature repository. So as I mentioned earlier, this Cassandra feature repository is directly associated, is directly getting the data from the Hive feature store or Hive feature resource repository. So from there, we are getting the historical information, historical feature, static features mainly about the customer and the restaurant. So this type of static information is directly getting feed into your machine learning model to make the predictions. And then we have some dynamic information, and those dynamic information generally comes from the client application like your mobiles. So when you make a particular order, okay, then at that time point in time, all the latest information which are available, those latest information, relevant latest information, are fetched from your mobile from the order, and then those are sent to this machine learning model. What type of this information can be? This information can be the time, at which time you have met the order, for which particular food you have met the order, from which particular restaurant you have met the order, what is your geographical location, and if what is the weather condition at that time, what is the traffic condition at that time. So all this type of real time situations are observed and sent to this particular model, and corresponding to the user and the restaurant and the food that you are ordering, the historical or the static information are fetched from the Hive feature store. And then once all the static and dynamic features are available at one place, then your model is used, the trend model is used, and the model makes the prediction. Once the predictions are made by the model, these predictions are sent back to your client service. Okay, basically your for example, that application server, and that application server in turn send the relevant information back to the user, like whatever order you have made. For this particular order, it is going to take like 35 to 40 minutes of time to be delivered at your doorstep. So in that way, all the information, the historical information, static information of the restaurant, about the user, about the meal, about everything is utilized. And not only this static information, but the dynamic information as well is collected at the same time, at the real time, and both this type of information are feed together into the trend model, and the trend model makes the prediction. Okay, and that prediction is sent back to your mobile device, and there actually you come to know the estimated time of arrival. Finally comes the monitoring the prediction. So it is not like the end. When you make the prediction, when your model is able to make the prediction, that is the end of the story. No, actually it is possible that after some point in time your model can start deperforming. Okay, your model is not making the accurate prediction. So you have to make sure your model is not only making the prediction, but it is making the accurate prediction all the time. For that particular purpose, what do you do? At regular interval of time, you evaluate your model, you monitor your model performance, and that is known as like monitoring the prediction. So what do you do actually in this particular step? You take the available outcomes from the outcome repository, and you store the predictions made by your online model and offline model into one more repository, which is the sampled prediction repository. So not all the prediction, but in timely manner, some of the sampled predictions, some subset of the predictions are stored from the online prediction and the offline prediction and stored into a sampled repository. Okay, in this repository. So in this repository, we have the predictions available. In this repository, we have the actual outcome available, like exactly what was the time of delivery and what was the prediction made by the model. Once you have these two information available, the prediction information and the actual outcome information, then you can combine these two information together, and then you calculate some important matrices, like you calculate the difference between the actual time of delivery and the predicted time of delivery. You monitor the difference, you make sure this difference is as minimum as possible. You calculate different type of statistical matrices, like you calculate R square, adjusted R square, RMSE value. So these are some statistics which are used to back sure our model is how our model is performing. Basically, these are the matrices which are used to evaluate your model prediction performance. And then you store all this type of information into some repository, maybe in a Hive table, maybe in a relational database system, and from there they are utilized for system monitoring purpose. So maybe they are using some dashboard, they are using some charts, they are using some BI tool to evaluate these metrics performance. Like over the period of time, these metrics are getting are becoming more and more improved. They are improving over the period of time, or they are getting worse over the period of time. So that type of monitoring is also done in order to make sure our model is making correct predictions over the period of time. So that is how end to end a machine learning, a data science solution is being implemented at Uber Eats. And I hope this particular case study will be very helpful, would be very helpful for you to understand the entire flow, or to understand exactly how machine learning or data science solution are helping the organization. Now, here I would like to wind up today's session here, and we have some time, and the remaining time we are going to utilize for all the questions. Okay, so let me go through again to all the questions, and I will try my best to answer all of your questions, as much of the questions as I can. Okay, so let us go ahead and answer these questions one by one. Okay, so again, I will skip all those questions that I have already answered before. I'm starting from the last actually. So because I assume, you will ask, the people will ask the relevant questions now. So I will start from the last. Okay, is Python used only for data science project? No, Python is not only used for data science project, but Python is also used for many application development as well. But there are two type versions of Python, like Python which is used for data science, or the libraries you can say which are used for data science are little bit different as the compared to the libraries which are used for the application development. Okay. So I'm it's not even able to answer the questions. You are asking too many questions. I'm really glad. But let me please bear with me. Okay, I will try to answer as many questions as I can. Okay, is more Python more helpful, or R is in data science? So Abhishek, as I mentioned, for both are are great programming languages, great statistical programming languages, but Python is catching more attention nowadays because all the latest libraries, all the latest enhancements are being done nowadays in Python. So Python is doing better job nowadays. In which stage of life cycle, project life cycle, we go for further feature reduction. Feature reduction is done in the data engineering or data pre-processing. Okay, we have talked about the data preparation phase of crisp DM life cycle, Rama Prabhu. So in that particular phase, we perform the feature reduction. From day one, no application will be perfect without these predictive analysis, right? Yes, perfect from the day one. You cannot perform the predictive analytics until unless you have the sufficient data available. Thank you so much for your time and clear query. Thank you for your very positive comment, Habibullah. Does the Uber Eats use Python for machine learning? No, they have used Ashish Spark because they are in big data platform and they have to deal with a very huge amount of data. So they are using Spark, and basically Spark further make use of Python as well. So you cannot directly use Spark. You will have to rely on some other programming languages like Python or Scala. So basically we call it PySpark. Okay, so which is actually used. Thank you, Sang, for your very positive comment. Can the project management professional work in data science? Not exactly in the coding part, not exactly in the implementation part, but yes, Kamal, the management professionals can work, can utilize actually all the findings, all the predictions, all the outcome of data science project in order to make their business better. Okay, Python R. I'm skipping these questions. Okay, then is it mandatory to have language knowledge? Yes, if you want to, work on the technical part, like you want to work on model development on your own, then yes, it is important to work. It is important. It is recommended to know the language knowledge. Which tool is better for visualization? For visualization, nowadays Tableau is catching quite a lot attention, but you can also use Python visualization libraries like Matplotlib. Like Plotly. Plotly is also very frequently used visualization tool package of Python. Which statistical tool are commonly used in machine learning? Python, R. Which algorithm should be used for auto suggestion? Auto suggestion is actually the chatbot, basically what you mean for auto suggestion. And another type of auto suggestion is the recommendation engine. Okay, so recommendation engine is also a way using which we perform the auto suggestion. Okay, so I'm not sure which context you are talking about, but these are the two things which are used for this purpose. Do we have to train each model each time someone orders food, or the model? No, no, so model is trained already. On all the trained models are restored in the model repository. When you make the order, the trained model are used, but the prediction is made at the real time. Okay, trained model are already there. You make the prediction online at the real time. What are the model methods available to test the model? So different models are evaluated and tested in different way. So depending on your target variable, different methods are used. I cannot talk about just one method. I'm a beginner. What should I learn first? You should learn some statistical programming language. Start with Python and PL SQL concept. Yes, machine learning can be used in all the areas. It is definitely domain independent. So waste management, agriculture field, it is being used in n number of areas in agriculture. Mainly it is being utilized to understand the impact of different supporting elements, like in agriculture, which particular two crops can give better result, what additional supplements can be can show more growth and more production. So this type of predictions are being made there. Thank you, Teja, for your positive comment. Any book to study than this webinar? So you can actually for this particular webinar, you can get in touch with the Cognixia support team, and they can assist you with the recording. They can assist you with the presentation as well if you are interested. So because I have already answered your question about the agriculture and waste management. When the Uber Eats launches, it already shows the expected delivery time, how they initially trained their model. So they initially, if they have started, if from the initial itself, from the beginning itself, if they are, I'm not sure if you are saying that, I hope you are confident on that part. But if they are doing so, then maybe, they haven't got all the perfect model at that point in time. So they have started using very minimum information, whatever available. So maybe at that point in time, their prediction accuracy will be very poor because their model was not trained on the enough data, on the sufficient data. They must have, uses some static information only at that point in time. Okay, and then that's why their prediction accuracy would not be that much good as compared to today's prediction accuracy. So PC also comes under feature engineering. Yes, Ramaprabhu, PCA is nothing but principal component analysis, a sort of dimensionality reduction techniques that comes under feature engineering. How can machine learning be helpful in best map? Vikas, please stop posting this question again and again. For the search bar, so when WW will be getting the certificate for, we will be getting the certificate for participation. Yes, you will be getting a certificate of participation in this webinar, and you will be sent your participation certification directly on your mailbox, to your mailbox. Okay. And okay, I have already answered this question. Okay, thank you, Alok. Thanks, Manoj. Are there freelance projects on working professionals can work on? Yes, there are many freelance projects available nowadays. So I'm not pretty much aware of about the channels, but you can definitely Google it out. So nowadays, some companies are also offering some freelance work on in the fields of data science and machine learning. Can operations related person can enter into data science? See, any person can enter into data science. There is no question, there is no restriction at all. The only thing is, like, some people who are already in the fields of data science, machine learning, mainly like in the fields of data warehouse, business intelligence, big data, it can be little easier for them as compared to the other participants. But there is no restriction like who can get into, who cannot get into. Maybe, some folks will have to pay more efforts. They will have to put some more efforts as compared to other. But anyone who has great enthusiasm, who has dedications, who can put efforts, can get into data science and do a great job there. Thanks, Manoj, for your very positive comment. Thanks, Ajay. Thanks, Pranay. Okay, Prabhat, can you please repeat your question? I will answer this question now. What are the organization in India working? Many Yogesh, so many banking institutes nowadays are working on data science and machine learning projects. And in fact, I have worked for a couple of Indian banks in India for data science and machine learning projects. Apart from that, manufacturing industries, construction industries, sales and marketing industries, they all are working on this type of data science and machine learning projects. And you can say almost all the big organizations nowadays are making use of data science and machine learning. Google Analytics is related to machine learning, data science. No, Google Analytics is actually the way using which you can, analyze your organization data in a more effective way. You can say it's kind of advanced BI. But Google has also launched their Google Cloud platform, on which they are also offering the machine learning, what you can say, services. Can I say this webinar is kind of machine learning? You cannot say this webinar is kind of machine learning. It's the live learning. It's the instructor-led learning program. Which statistical program you should learn? You should learn Python. I hope you mean which statistical programming languages. Then I would suggest you to learn Python. What file system does Spark support? And Spark basically, is used at the top of a big data platform like Hadoop distributed file system. So basically, it supports Hadoop distributed file system, but it comes along with its own data structure, its own data type. At a lower level, actually, it makes use of RDD, and then it also have data frames, Spark data frame, which are mainly used for data science and analysis purpose. You will be mailed your certification, Pranay, on your email ID, to your email ID. Thanks, Neha, for your great comment. What will be the roadmap to become a good data scientist? I'm new to data science. So the roadmap would be, firstly, as I mentioned earlier, please make yourself comfortable with PL SQL, ETL concept. Side by side, you can also start learning Python, and then you will learn some visualization tool using Python packages like Matplotlib, Plotly, or you can also go for some visualization tool itself like Tableau, ClickView, and then machine learning concepts, then how to implement the machine learning in Python, and that should be your way ahead. What is the future of blockchain? Sorry, Vishal, I am not the blockchain expert, so would not be able to answer this question perfectly. What is your recommended best for career in data science, a startup or big IT like TCS? If you are fresher and you want to get into data science, if you have two options like some big organization like TCS or a startup, then I would recommend you to go ahead with a startup, Vijendra, because as a fresher you can get more opportunity to directly work on some data science project or to be a part of data science project as compared to some big organization, because the big organizations generally have more senior folks, more experts available to work on this type of projects, but a startup can give you this opportunity, can give this opportunity to freshers as well. There are a number of certifications available for data science, and some industry recognized certifications are also available. Cognixia is also providing certification courses on data science and machine learning. Please get in touch with the support team for further details on certification and training programs. I'm a discovery data analyst. What type of opportunities can I have in data science? You are already in a pretty hot areas, Yuva, and I am pretty much confident that e-discovery area is also making use of a number of data science and machine learning implementation. So I'm not that much familiar with this particular domain, but you can Google it out a little. I'm pretty much sure you will get a number of links. E-discovery is pretty recent and pretty new areas, and it is all about making discoveries or research based on the data. So I'm pretty much sure some models like data mining related models, some more models based on association analysis, probabilistic models. They must be having some direct application, some direct use cases in the fields of e-discovery, like outlier analysis, some statistical analysis. These can be utilized there directly. Thanks, Mahesh, for your very positive comment. Thanks, Mohit. Thanks, Pranay. Thanks, Srinivas. Do we use regression method in prediction? Any other method? Yes, we use prediction. We use regression as well. In fact, we use different type of regression. Like we have logistic regression, linear regression, polynomial regression. Apart from that, we, as I mentioned earlier, we have different type of algorithms like classification, forecasting, time series analysis, cluster analysis, outlier analysis. So there are many algorithms available, Amit. Thanks, Jadip. Thanks, Naman. Thanks, Kamal. Kalai Muthan, sorry. Thanks, Ravi. Thanks, Mohammed. Thanks, Mahesh. Thanks, Sarah. What are the most common errors which are committed, or the most common reason of failure in machine learning project? Lack of data or improper treatment of data. That is the most common mistake. We have some important features, some important information generally available in our data, but we do not prepare the data in perfect way, and we result into inaccurate model. Thanks, Pranay. Thanks, Tapan. Thanks, Suhani. Thanks, Teja. Thanks, Samarjeet. I'm from mainframe programming field for past 8 years, trying to move into data sciences. Is it possible to move into data science field literally as a fresher? Yes, yes, Rama Prabhu. You already have programming experience of 8 years of programming experience in mainframe. I do not see any challenge with learning Python programming. Thank you, Nikhil. Thanks, Rajesh. Thanks, Ram. Gopinath, any data science certification course in market? We have plenty of data science certification courses in market. For more details, please get in touch with Cognixia support team. Prabhat, I would request you to please ask your questions again rather than going behind. I would like to answer those questions for which participants are still waiting for the answer. They are still there in the webinar. How Hadoop is related to big data? So big data is a concept. Hadoop is a platform that implements that concept. What is the role of business analyst in data science? So what additional skills he needs to have? Business analyst is responsible to make the data science team comfortable with the business related questions, with the business related aspects of the project. So business analysts are the business expert or domain expert people. They provide their business knowledge or domain knowledge to the technical persons. From environment engineering background, currently I am involved in air pollution data analysis. How can I apply knowledge of data science? You are from the very good domain, Surya Sis, and basically from environment and EHS. Basically, I myself have worked on one of the EHS project in the past. It was about like classification of the events, EHS events into hypo and non-hypo categories. But nowadays, many organizations are working on the environment impact and environmental policies. They are conducting many research about the product, about the consumption, about the treatment of the waste treatment, and how effectively all these things can be done. What can be the impact, or what can be the the side effect, you can say, of the treatment, and many of these research are going on in the environment, mainly in the environment areas, EHS areas, which use on which you can using which you can work on, or for which you can implement data science or machine learning concepts. Difference between Cassandra feature store and Hive feature store. Sashat, I would love to answer this question, but that it is not that simple to answer at this point in time in one line. Thanks, Seha, for your very positive comment. So, Rajan, I have already answered. Hadoop is an implementation of big data. Hadoop is a platform. Thanks, Ritu. It depends, Dharamji, Dharmendra. This cannot be stated very straightforwardly, like how many openings are there in which organization. But yes, the good thing is data science openings are there in all the industries and all the organizations nowadays. What is data lake? How it is different from data warehouse? Data lake is nothing but when you implement your data repository or your data warehouse by using some big data platforms like Hadoop. Generally it is called as data lake. Otherwise, when you use the relational database system and you come up with the standard models of data warehouse like data mart, star schema, snowflake schema, it is referred as the data warehouse. The salary according to INR, so it depends actually. So but data scientist is supposed to be the highest paid job across all the geographies. If data analytics is subset of data science, what else falls under data science? So I think we have already talked about it, right? So what different phases we generally work on while working on a data science project? Thanks, Brahmanand. I'm sorry to ask, how about on-site opening with respect to data science field? Mainly data scientists are supposed to work on site only. So generally, you are supposed to work closely with the business folks. So there are plenty of on-site opportunities are available. Descriptive analysis means, please. So descriptive analysis is all about, when you want to find like in short, you want to perform some correlation analysis. You want to perform what was the reason behind something, rather than performing some predictive analytics. You want to perform the RC analysis. You want to know the root cause. Then this type of analysis, you are looking mainly for some sort of business questions asked by the business. Then you make use of descriptive analytics. Thanks, Amol. Thanks a lot. Yes, skills like MongoDB or Flask can be very, very useful in data science. And basically, Flask developers nowadays are needed in order to implement or in order to come up with the application development for data science. So yes, for sure, Shubham, thank you. So we can term data science as next step of advanced analytics project, right? Yes, definitely you are more than 100% correct. It is like a next step of business intelligence or next step of advanced analytics. What quality attributes data science with respect to delivery standpoint? A very typical question. Sorry, I will skip this. You will get all the upcoming webinar information from Cognixia support team. Please get in touch with the Cognixia support team. How hard is it to change a stream from QA to data science with 1 year of experience? You have just started with your career. I would suggest it is definitely not late, and it is very easy, for someone who is just starting with the career. Please go ahead and start learning Python right away and make progress towards the fields, towards data science and machine learning. What are the best language, Python or R? Definitely Python nowadays. I'm not I'm not demotivating the people who work on R. I myself started my career uh, using R only. I still work on R, but yes, for the beginner, Python can be the better option who are starting something from scratch. Tell me about SAP predictions, please. Not it is not in the scope. Okay, so SAP has got their their predictive analytics platforms. They have got their IoT platform, SAP Leonardo, SAP predictive analytics, and SAP website. One SAP website is there for all this type of training and certification program. Open SAP. Please go there and explore that for more details. I want to be good in machine learning. From where to start? Start with the Python programming first, and then start reading some books on machine learning. Okay, thanks, Balaji. Can you please tell the sources of PySpark? I'm not sure what the question is, and the person has left, it seems. So I'm skipping this question. I have already answered this question. What is data lake? How it is different from data warehouse? So thanks, Rajan. Thanks, Varun. Could you please explain the difference between the exploratory, descriptive, and perspective? We have already gone through this. Thanks, Abibullah. Thanks, Sri Devi. How to develop interest in Python? I get bored while starting the coding in Python. Make sure, see, data science is not boring at all. All the latest and greatest thing is happening in the fields of data science and machine learning. Make sure you are updated. You are reading the latest blogs, the websites. You are surfing the websites related to data science and machine learning. All the latest and greatest thing which is happening in the fields of data science and machine learning. Try to make yourself updated about these things, and you will not get bored for sure. Yogesh, please get in touch with support team for this question. Yes, basic knowledge of the Python will be sufficient to at least get your career started, and then gradually you can become more and more confident, more and more experienced in other areas of data science and machine learning. Yes, whoever is having 1 year, approximately 1 year of experience, is Neha and everyone, definitely it is the beginning, and you can go ahead and start your career in the fields of data science and machine learning. If you are really interested, start learning some programming language like Python at the beginning. What is the role of Spark in training or prediction? So Spark is just like another prediction statistical tool like Python or R. Spark Sparks is mainly has been designed mainly to work in big data environment on huge amount of data. So Spark, is doing great job there. Thanks, Tushar. Thanks, Ritesh. I am 45-year-old with for 15 years, 15 Oracle DBA. Is okay to enter as fresher in data science. Is it okay? And I hope you must be having some domain and business experience as well, Chandrasekhara. And it is never too late. Then it is definitely never too late for anyone. What I would suggest you is what I can see actually. Sometimes it becomes really challenging to justify the previous experience. Okay, and like why you have changed your career or your technology after 15 years or 20 years of experience. So sometimes that becomes a little challenging, but if you have dedication, if you have consistency, if you can show consistency, if you really can put extra efforts, then it is never too late. Yes, Bharat, we will definitely plan some more webinars in future. Please get in touch with the Cognixia support team for the upcoming session details. Yes, whoever have asked the question and I have already answered the question, you can please feel free to leave the session right away. Okay, I'm just trying to go through some more questions. So if I can answer some more questions, I can see many hundreds of participants are still waiting. So I'm just trying to answer those questions. If you think your questions have been answered, you can please feel free. And again, thanks all of you for making this session a great success, and looking forward to get in touch with you in future. Why did you say it takes around 3 months to complete a data science project? I didn't say it takes 3 months, but it can take generally it takes around 3 months or more than 3 months. Generally it takes at least more than 3 months, okay, not less than 3 months. And data science project generally have a specific project objective. So that's why it is not something like you are developing a product or something. You are performing some sort of analysis, then you build the model, you deploy the model. So generally it takes at least 3 months, and somewhere between 3 to 9 months, 3 to 1 years. Thanks, Yuva. Thanks everyone. Thank you, Suresh. Thanks, Chandan. Sarthak, I have already answered your question. Difference between data lake and data warehouse. Thanks, Satish. Thanks, Shiv Prasad, for the great comment. Thanks, Chandrasekhara. Thanks, Gopinath. Thank you, everyone. Thanks a lot for all the positive comment. Thank you a lot. So finally, Python, if we consider for PL, data mining, machine learning, and little bit of Hadoop, yeah. Thanks, Malal Kappas. I hope I'm pronouncing your name correctly. Okay, thank you everyone. So I tried my best to answer all the questions, but I know plenty of questions are still left behind, but we have some time limitation, and definitely I will not be able to answer all the questions. But I hope all of you have enjoyed this session. Thank you again all for joining this session and making it a great success. And looking forward to see all of you in upcoming webinars, in upcoming sessions, in upcoming training programs conducted by Cognixia. And thank you everyone for joining this session. Have a very good day ahead. Good night. And I hope you have enjoyed this session. Bye. So I would like to conclude this session here. And we are already half hour above and over the time, defined time limit. So we can wind up the session here. Thank you all. Bye.